This is a 75 series actuator with a 24 volt DC positioner board attached. This positioner board is set up for fail open or fail counterclockwise position, which is considered a reverse acting actuator. So with this video, we're going to show how to set this actuator up. Some of the tools we need a fluke meter or a multimeter that can be set on ohms so we can read the potentiometer. We need a small screwdriver to make all the connections with, and a 1/16 Allen wrench to set the cams with. We also need a loop calibrator. This is going to give us our input signal to the board. This particular board here is a 4 to 20 milliamp input board, so we'll need a 4 to 20 milliamp calibrator. Alright, to get the calibration started, we want to make sure that the actuator is in the clockwise position. We always put the indicator cap back on it so we can see where it's sitting at easily. So as you can see here, the position of the actuator is in the clockwise position. And we want to hook power up to it. 1 and 2 is where we hook our 24 volt power in, and then on 10 and 11 we want to hook up our loop calibrator input, 10 being your negative and 11 being your positive input. And this is where we put our input in. Now some of the functions of this board here, we're going to go underneath here. We have a potentiometer gear here on the main shaft. Right here, this little plastic tooth gear. And also I just wanted to make a note, the wires hooked in 8 and 9. This particular unit has an output board, and we're going to go over the calibration in another video, but just didn't want to confuse someone with the 8 and 9 wires being hooked into the board. We're going to go around to the other side of the unit, and you can see over here the potentiometer on the unit. We have a potentiometer gear here, the little small gear. You can see it's engaged with the gear on the shaft. So that's going to be important for setting up the calibration of this unit. And also on top of the board, we have 3 small potentiometers. Here you've got an AH, which is your deadband, a range, and a 0. So these are going to be critical in the calibration of this unit. So now what we'll do, with no power on the unit, we want to take our multimeter with it set on ohms, and we want to check the location of our potentiometer by putting the leads on the white black wire and the purple wire. Once we get our leads on these wires, we want to take our potentiometer reading. Right now, as you can see, we're at 850 ohms. The setting on this should be, or I'm sorry, this is 0.850 kilo ohms, which is 850 ohms. So what our potentiometer should be reading, with the actuator sitting in the clockwise position and our leads on our white and black and purple wire, should be reading between 80 and 90 ohms. So in order to adjust that, what we need to do is we need to go in up underneath the board here with our fingers, and we want to get a hold of this gear. I'm going to come around here so you can kind of see what I'm doing. And we want to turn this gear with our fingers. You can see it turning, and what that's doing is that's turning the potentiometer, and our reading is going to change. So what we want to do is we want to turn this around until we read between 80 and 90 ohms. So we went a little bit far. So we're reading about 85, 86 ohms now. Alright, so now we've got our potentiometer set up. We can take our leads off. The next step we want to do is we want to take a screwdriver and we want to turn our range all the way clockwise. So you want to turn it clockwise around till it hits the stop. The flat of the screwdriver should be between 11 and 5 o'clock across the potentiometer. And then we want to do our 0 the same way. So we take it, we turn it clockwise until it's at 11 and 5. All right, now we've got the actuator set up, ready to put power to it. All right, we've got our power hooked up to the actuator. We've got our input signal hooked up to the actuator. After we've got our pots rotated clockwise on the range and 0. What we want to do is we want to set our input signal to 4 milliamps, and then we'll apply our 24 volt power to the unit. And when we do this unit's going to start rotating in the counterclockwise fashion or to the open position. And note at the beginning of this video, this is a fail open actuator. So we've got power on it. You can see the indicator is rotating counterclockwise. And it's going to rotate around not quite to the full open position. And you can see here, it still needs to go a little bit more. So what we'll do here is we'll take our little screwdriver and we'll go in on our 0 potentiometer and we'll turn it counterclockwise a little bit, and then you notice that the indicator is moving. So we'll just keep adjusting it till it gets to our 90-degree position. Now we've got this position here set up, and what we'll do now is we'll flip our loop calibrator over to 20 milliamps. The actuator is going to start rotating clockwise, and it's going to rotate around not quite to the closed position here, and we're going to adjust the range. We'll adjust it in a counterclockwise fashion, a little at a time, till our indicator gets around to the closed position. All right, we're there. So now the range and the 0 potentiometers here work together. So what we'll need to do is we'll need to give it 4 milliamps again and go back to the open position. It's more than likely going to need to be adjusted a little bit more, fine-tuned. It didn't quite make it to the full open position, so we'll adjust it counterclockwise on the 0. All right, till we get to our full open. All right, now we'll go back to 20 milliamps, go to our clockwise position, and it's going to need a little bit of adjustment too. You may have to go through this cycle here 2 or 3 times to get the full range set. Okay, we'll give it 4 milliamps again. Go back to our counterclockwise position, see where we're at on this position. Should be getting real close now to being where we need to be. Maybe just a hair tweak. Okay, we're there now. So we'll go back to 20 milliamps, go to counterclockwise position again. Once you get this set up, you shouldn't have to tweak it anymore. This is the first step of calibration. Once it's done, it should stay within its range every time. We'll tweak the range just a hair bit more. There we go. All right. So we'll go back to open, give it 4 milliamps, verify that position. All right, we did go full open. So now what we want to do, we've got our range set and our 90-degree range. Being this is a positioner board, we want to verify that it is tracking correctly. So what we'll do on our loop calibrator, we'll give it 12 milliamps. And we want the actuator to rotate around about 45-degree position, which it did there. So we are tracking the input signal. Now, once we get that set there, what we want to do now is we want to go down underneath the board, and the 2 lower cams on this board, this unit has an M2 option also, which is switches to indicate your open and close. But the lower switch here we've got the very bottom cam. We want to rotate it around. There's a little lip on it. You'll see it coming around here. And we want to put 4 milliamps on the actuator. That's going to put us back to the full open position. The cam on the second cam up from the bottom, we want to rotate it around here. We'll take our 1/16 Allen wrench, we'll put in the cam. We can rotate around. Now that switch will click, and I don't know if you can hear it in this video or not, but you want to set the cam not where the switch is clicking. You want it to be right on the edge of it, because these become safety stops in case you lose signal. They're not used any other time other than that. Now what we want to do is give it 20 milliamps. So we're going to rotate back around to the clockwise position. Okay, same thing on the very bottom cam. We want to come in and put our Allen wrench in. We'll rotate it around. Like I said, you want to rotate it around to where it's not hitting the switch. There it clicked. Back off a little bit. We'll tighten the Allen screw up. Alright, now we have our switches set. Now, earlier I was talking about this being a fail open position actuator. So what we want to do now is we want to give it 12 milliamps and go back to the center position. Once it gets to the center position, we're going to cut the signal off from the actuator. So we're here at the 45 degrees or 50% position at 12 milliamps. Now we're going to just cut the power off on our signal. Once we do that, this actuator should rotate around to the open position or the full counterclockwise position. And it's going to stop. And it stopped on that switch that we just set. And what we want to verify is that our switch is set correctly. We'll cut the power back onto the unit, and when power is cut back onto the unit, it should go, on the loop calibrator, it should go back to 12 milliamps. It should go back to the 50% position, and it did. So now we know our switch is set correctly and our unit's calibrated. We want to give it 20 milliamps here to carry us back to the open position, or to the closed position, or clockwise position, and with the units ready to be mounted and installed in line.